Hello and welcome back. Today I want to share a seminar with you that I got to attend at Toronto Audio Fest. The seminar was hosted by Varney from AV Room Solutions on YouTube. So AV Room Solutions offers short educational videos on acoustic and audio issues you may experience and how to fix those issues. Norman is very passionate about people experiencing the full potential of their audio setups, and he wants people to get their money's worth. I personally like that throughout this seminar, Norman makes it very clear that these improvements can be made for free. After I attended this seminar, I got home and decided to take some measurements of my own listening space, and I'll throw those results up on the screen for you now. So just a quick disclaimer before we jump into the seminar. Ironically enough, this seminar took place in an acoustical nightmare of a room. So in editing, we'll try to fix that for you, but it is what it is.
I'm Norman, and what we'll be covering today is all about sound quality and power quality and what the typical audiophile is dealing with at home, his current conditions, his typical conditions, and what would be nice to, what is achievable, what would be nice to obtain, and how to get there, how to get from existing to desired. And we're going to talk about, first, about acoustics, and then we're going to talk about electrical. So those are the things we're going to cover. Let's see. So we're going to talk about the fundamental sound quality attributes and for critical listening, and how far off the typical listening. And I should say, if you've got questions, try and remember them or write them down. I'm going to jam through this really quick. And so my favorite part, though, is at the end, opening up to you guys and getting some real world problems and trying to help you out. So I'm going to ask that you hold off questions until later so that I can get through, so we can complete this. So how far off the typical listening environment is from the desired, and what these attributes mean to the experience, and how these sound quality characteristics are measured. And finally, solutions to these common problems. So there is a hierarchy regarding that, and these are all fundamentals when we're talking about sound quality, noise control, and power quality issues. To me, these are fundamentals, and if until we have what I call a neutral playing field, we're easily confused because of the influence of these distortions that we are not wanting, that are not a part of the original recording, that are not a part of the artist's intent. And we'll go through the hierarchy. And so we often talk about specifications. And this is great, but there are definitely specifications that are meaningful and specifications that are, that are meaningless. So for example, when we are talking about looking at electronics, we're often looking at, well, what's the frequency response of this speaker? Those are important, certainly, but do you know, for example, what your ambient noise floor is? No hands. Do you know what your reverberation times are? Is there a nod? You know? Excellent. Very, very rare. I applaud you. Do you know what your ground impedance is? No. Anybody? No. Okay. These are important. So this is my big, bold statement. I'd say that 90% of the audiophiles are experiencing less than 50% of their equipment's potential. And I would say that's a really conservative statement. So think about that. So when we don't have the fundamentals in position, and we're constantly after audio nirvana, what do we typically do? We're ignoring the important elements, the important measurements, the fundamentals, and we're doing the fine tuning, and we're completely forgetting about the coarse tuning. So I believe there's several reasons for this. One, the audiophile may be inexperienced as to what the potential is. Everyone has a reference, right? You all have an idea. What's the best sound quality you've ever experienced? Well, that varies amongst you, right? Your bar may be higher or lower than mine. So it's all a matter of what you've experienced. They may be unaware of the obstacles that are preventing a better experience. They may not know how to control these obstacles, and that's where I fit in. And there may be constraints preventing them from achieving their goals. There's always constraints in a room. A room is never perfect. There's always something that's going to be that's going to make it imperfect. But the big one is they're told the answer is to buy better equipment. And that's not always the case. In fact, that's not usually the case. There's, for example, you can have state-of-the-art equipment, but if it's in a poor environment, it's never going to perform well. You can have mid-fi in a good controlled environment, and it'll kick butt over the state-of-the-art every time. That's something to consider. So in other words, the equipment can never overcome the acoustics. It's something to think about. So in this graph, I'm showing what our audiophile is doing in the meantime. So on the left-hand side, this is the typical action taken to improve the audio experience. And on the right-hand side, this is the typical impact. If you notice, they're almost in inverse of each other. So most people that are here at the show they're making tweaks, they're doing upgrades, they're buying new equipment. They're not dealing too much with acoustic treatments or physical setup. They're not doing much at all as far as structure-borne vibration or resonance isolation. And yet, look at how much of an impact it has on your experience and the performance of the equipment. Really, I mean, this is your investment, right? You're buying expensive equipment for a great experience. But if the environment isn't conducive to it, you can never win. So that's what we're going to be discussing here. So I kind of look at it as far as importance, setup, calibration, and acoustics is going to outweigh the electronics. So who is the audiophile? We need to kind of define who the audiophile is. Oh, I just missed it. So it's a person desiring to reproduce the artist's musical work accurately through an audio playback system in a small room. In our audiophile scenario, it's a space that meets the following criteria. Will likely apply sound source frequencies whose wavelengths are longer than that of the largest dimension of the space. We're talking small room acoustics. There's different disciplines for small room acoustics versus large rooms, or certainly between performance venues and playback venues. We're talking about playback. We're talking about the room disappearing. So we just hear the recording. It incorporates shorter decay rates than the performance spaces and has strong early reflections compared to the direct sound. In addition, our typical audiophile room includes the following acoustical characteristics. Decay rates that vary uniquely and wildly by frequency, and I'm going to show you some examples of real-world conditions. It has unique room modes and a high ambient noise floor and only standard electrical service. So ideally, the goal is a neutral environment. It doesn't add or subtract, and one that does not introduce unwanted vibrations. And those unwanted vibrations can vary. They can include reflections, appliances, footfalls, electrical noise, plumbing, outside noise, resonances, buzzes and rattles, even electrical interference or buzzes. So a neutral environment is the goal. This is the foundation and is our reference for making value judgments. So if the environment is skewed, then so are our judgments. If it is skewed, then so is our experience. Here is the average listening room versus the desired. So for example, ambient noise floor, we're typically dealing with a a noise floor of about 40 dBA. We would like to have one that's about 18 dBA. That's a significant difference, meaning you aren't going to hear the low-level details in the recording. You're not going to experience the dynamic range that is in the recording. Dynamic range meaning, you're dealing with maybe 60 dB without cranking it to the point of ears bleeding. You can always do that in a safe environment. Let's just figure our peak is about 100 dB, okay? Something fairly realistic. Well, our desired, if we got the ambient noise floor down, is 82. That's a significant difference in dynamic range, correct? Frequency response as far as reverberation can vary more than a second. We want to have that under control in less than half a second. Room modes can vary easily, plus or minus 12 dB. We're talking a 25 to 30 dB difference. Remember we were talking about speaker response, plus or minus 3 dB. Well, then you put it in your environment, and it's going to be maybe plus or minus 25. That's serious, right? And for example, the average Joe, when you guys walk into one of these rooms, probably the first thing that you pick up on is the bass, the tonality, the extension and the articulation of the bass response. And so this is how important getting the room modes, and they're difficult, believe me, but how important it is. And then vibration isolation, typically nobody's doing a darn thing, and you should be doing everything that you can. You want to achieve more than 90% control over that. So noise floor, what that means to you as far as the experience. A high noise floor is going to limit the dynamic range. It's going to offer poor low-level resolution, and it can also mean distractions. Like when the HVAC suddenly turns off, you may have not realized that it was on at the time, but when it suddenly turns off, all of a sudden you go, or when it turns on, it's a distraction and it pulls you out. And in the meantime, it masks low-level detail and dynamic range. Reverberation. Limited dynamic range again, masking of low-level details, poor intelligibility, tonal and spatial reference and interference. This room that I'm speaking in is a great example. Articulation. I mean, with the high ambient noise floor and the reverberation, I've got to hold this thing close to me so that you guys can hear above and can understand what I'm saying. And if this were stereo, you can imagine this bouncing back and forth. Imaging is just going to be a blur. So specific imaging in the soundstage is not going to happen when we've got high reverberation. Great example, huh? I wish it weren't here. Room modes. Again, nonlinear bass response, obviously, and inarticulation and tonal influence. I'm going to talk about this graph and a test that can be done. And then lastly, mechanical isolation. Resonances, buzzes, and rattles can cause tracking errors in tonal and spatial, etc. We'll cover this in a little bit more detail as well. So under such conditions, can we expect to hear subtle equipment changes? Probably not. Can we expect to make fair assessment? Definitely not. And might we be compensating for system anomalies? If we've got, now a lot of these things, room modes, reverberation times and so forth, are tonal. So they're influencing particular frequencies into your ears that are not on the recording. So you're being influenced by whatever those frequencies are. And so when you're purchasing whatever, new equipment or new cables, you're being influenced by that. And you may be compensating for that. And then you make a change or you move or something like that, and that changes again. And so you're constantly in a state of confusion, chasing your tail, because the conditions, the fundamental conditions are not fair. They're not neutral. They're not natural either, and nor are ideal. So now this is I appreciate it's a very complicated graph. And online on my website, I have a YouTube channel, and this has an audio background. I suggest go there and check it out. What I do is I just play a little bit of music, and I'm taking each of these frequencies and I'm boosting them 12 or subtracting them 12 dB, and I go up the frequency response. We don't do a good job of communicating well with audio. But this is kind of the description that we often use when we have excess or deficiencies in these different frequencies. And audio reviewers will often use this kind of terminology. And it's okay. It's just nice to try and really nail it. What are we talking about? When we say it's honky, that means there's a good boost at about 500 hertz. You guys probably don't realize that. If you did, then we'd have a better chance of communicating with one another. So, acoustical objectives. We want to make the room sonically disappear for the playback system and control the influence of structure-borne and airborne sound vibrations. I don't think I need to go into that. With technology moving on, there's always improvements in the details that we can get, and it's more affordable to do so. There are still, I just want to emphasize that there's so many measurements that we can make that we can't hear, and also vice versa. There's a lot of measurements that there's things that we can hear that we don't know how to measure yet. And it wasn't until about 1967, Richard Hersey came out with the means of correlating. It was because we did not have the computer power until 67 to be able to measure frequency, amplitude, and time together. And it wasn't until about 1980 or so that was even affordable for big companies to get. It wasn't until about the 1990s that became affordable for people, for professionals like me to do. Now and I still come with that kind of equipment and can take measurements. But now, as of the last couple of years, there's an app. And you can take it's like $55 for an app that works on an iPhone or on an iPad. It's specifically designed for it. It does a pretty darn good job, and it allows you to make an impulse response in your environment and send the wave file to me via email. And then I can take it apart, and I can give you a really good idea of what characteristics your room, how it's behaving, how it's performing, and how to control it. What kind of acoustic products, where, and in what quantities. That's fantastic, and that's technology working for us. Same thing with power. There's many things that we couldn't measure before that we can. There's many reasons why we need to measure some things now that we didn't used to before because of technology. So the results are just about elevating our experience, making our investment more worthwhile, making it more enjoyable. This too is a busy graphic. I just want you to focus down here. So I've got 3 columns here. One is acoustic control, one is control measures, and one is the control benefit for each of these things. And I want to discuss these to make one particular point. So you guys are all probably very familiar with how important speaker and listener positions are in the room. And you guys have probably spent a lot of time optimizing that for bass response, for sound stage, for timbre. So your control measures are going to be room locations, and your control benefit is going to be bass response. Your toe in is going to be angles, and your benefit is going to be sound stage and timbre. First order reflections is going to be addressed with absorption or diffusion, and that's going to control spatiality and timbre. Reverberation times is going to be addressed with absorption. That's going to improve resolution and dynamics and spatiality. This is the one that I want to point out. The biggest bang for the buck, and you may have heard me say this before, is structural or mechanical isolation of your loudspeakers. So your loudspeaker is a source of vibration, and in our typical construction, everything is hard fastened to each other. And so when the cabinet vibrates on the floor, that vibrates the wall, that vibrates the ceiling, and hence why you can hear the subwoofer at the other end of the house. If I isolate the subwoofer from the structure, it will no longer be heard at the other end of the house. So from a mechanical isolation point of view, isolating the loudspeaker is a huge benefit. It addresses all of the sound quality attributes. So for the listener, it's going to improve spatiality, timbre, articulation, dynamic range. Like I say, all the sound quality attributes. I don't know of any acoustical product that will do that, except for mechanical isolation of your loudspeaker. And in addition, it will also address noise control, going to adjacent spaces. Again, I don't know of any acoustical product that will do that. So it's the most powerful acoustic product I know of. It is also the least expensive and the easiest to implement. So think about that one. Biggest bang for the buck. So with sound quality, with acoustics, with power quality, with noise control, it's always, I just want to emphasize that it is a scientific approach, if you will, to how you go about this. We don't guess. We don't just haphazardly try different things. There's definitely an approach to take. So I'm going to give you an example talking about noise control, because it's the easiest probably to do. So the first step, whether we're talking power or we're talking sound quality or noise control, is we're going to evaluate the noise environment under existing, or if it's not built yet, we're going to model it. We're going to make it as close to we can as what we anticipate existing will be. And then we're going to understand the means of each noise path in terms of octave band sound levels, measure or model the sound energy levels of each path, measure or model the total noise of each path in those frequency spectrums. And then step 2 is going to be to determine the acceptable noise level or criterion at the receiver location. So we have whatever it is, some energy that we've got to deal with. What is the acceptance level of the listener? And that's going to vary. Both of those are going to vary. We have to know what the answer is to both of those, correct? Then 3, we're going to obtain the difference between the two. So now we're going to prioritize each noise path. There's going to be multiple noise paths, and we're going to establish physical, budgetary, decor, local code, and other constraints. And then we're finally going to evaluate the various designs, and we're going to meet the two. We're going to match up the two. So every room's different, and the approach is that we are going to take the existing conditions, and we know what the goal is. What is the solution to get there with all the constraints and so forth? And my job is to educate you. There's always going to be options. There's going to be multiple ways that this can be done. And what's going to be the driving force on those are going to be the constraints. So I'm going to inform you as to what the pros and cons are of different solutions so that you can make an informed decision, whether that's budgetary or time or physical or whatever the constraints may be. Just a graphic showing you, for example, with noise control, in this situation, I'm showing 9 different paths that this copy machine can be annoying to that person working there. And so there's 9 different paths that have to be studied. There's 9 different possibilities, and there will be combinations made of what the solution is. And look, the solution could be as simple as earplugs. So here's your typical noise floor right here. And we're just going to use triple F as 100 dB as the dynamic range that we want to experience. So we're dealing with about 60 dB. We can, and we would like to get down to about 18. So that 22 dB difference is really significant. That's a lot. And to me, a lot of musical enjoyment are the microdynamics. To me, that's where a lot of the artist's emotion is and portrays the emotion to me. I love to hear microdynamics, not just the macro dynamics. And most times that's given up. It's mapped. So here's what's called this is regarding HVAC. And this guy had, actually, it's a darn good HVAC system. So this is, the heating ventilation system on. What is the ambient noise floor with it on? And this is after we made some treatments. And so now he's down where it's great, it's desirable. Not typical. That black line, that is pretty great. We were talking about reverberation times in rooms and how wildly different they are. They are so different in that everyone's room, all of our rooms are unique as our voices or our thumbprint. They're all different. This is an example. I took, this was a few years ago, and I just took the last 50 rooms that I measured. These are listening rooms. These are critical listening rooms. And I averaged them. Look at that. It's crazy. We want to have linear. We want to have, a pretty flat line from 125 hertz on up. Look at this. Over a second way down here. Over a second way up here. It's crazy. This is what it means. If I've got, let's say, a reverberation time of 1.5 seconds, like in here, if I turned around and I said back, bend, back, you really wouldn't have an idea of which word I was saying. You might have an idea, but the T, you heard the vowel, but the T was being covered. It was being masked by the reverberation lingering in the room. If I get control of the reverberation times, that consonant is then revealed and you can hear the T. But before, the B just covers it. It just booms, it just lingers and bounces around, and you don't hear that because it's so short and quiet. This was a media room. When I do reverberation time measurements in a room, I'll do 9 different locations typically, and each one of those locations is an average of 7 reverberation measurements. So this is the media room carpeted, 9 different locations. Notice how they vary quite a bit. For one, look at the reverberation. It's quite a bit different from that average that I saw. Here we got reverberation times that are just crazy. This is carpeted too. That are crazy up at around 2K. But notice how they vary significantly from seat to seat. And then when you get it under control, this is a product that we make called the frequency response panel system. It's super linear and it no longer varies from seat to seat. So every seat has a much better and similar experience than up here before treatment. This is another experiment that I did. This was a controlled experiment where I had a room. Again, look at the weird, these are all small rooms, but look at the weird reverberation times. In yellow, this is the before, again, a carpeted room. And my experiment was to do the best I could with your typical 1-inch fiberglass panels. I don't care if they're 1 inch or 2 inch, they're only going to be effective down to about 500 hertz. So I did my best adding or subtracting panels to get to where the ideal is. I wanted this window of between 0.25 and 0.35 or 0.4 seconds. This is the best I could do. So I end up over-absorbing in the high frequencies. And look, I don't do a darn thing from 500 hertz on down. So in other words, I'm missing the bottom half of the piano completely. It's mid-range. And from mid-range on up, I end up as best as I could, I still end up getting it too absorbed. So it's not just one particular product. We're talking a wide range of frequencies. It's going to require different types of panels. So if it requires different types of panels, it's also going to require different locations to do to perform different work and at different quantities. So to do it right, it's the right type at the right location and the right quantity. So we were talking about room modes and articulation. So this test is called the Music Articulation Test Tone, MAT test. And it's a gated sweep. It's a 16th of a second on, a 16th of a second off. It sounds like this. In the red here, this is before treatment. You can see that it is not very articulate, and it sounds like this. Okay? So this is after our treatment, and it's nice and articulate. It starts and it stops. And you don't have that slurring, you don't have that ringing. And again, we're just talking about, from low frequencies up to mid-range. This, again, we can talk about more of this at my booth. This is all about isolation and equipment isolation. With all of these products, understand that there's a standard test that can be performed and has to be performed in an accredited acoustic lab. And anybody who sells any acoustical products should be publishing those reports for you to see online. We do that with all of our products. No exception, the transmission vibration transmissibility test, which is done with an impulse hammer. This is an accelerometer under the device, hit with an impulse hammer. It shows noise. It shows our product, and this is a rigid product. It's an aluminum cone, and I want to point out the peaks. Those are resonant peaks of that cone. Those are all in the audible range. Those are amplified. Those resonances mean those are frequencies that are being amplified. Those are louder than without. If I change the product material, if I change its size, if I change its load, etc., if I also change, because it's going to interfere with whatever the resting platform is, this curve is going to change. So it will never be consistent, it will never be neutral, and it will never be repeatable. With proper installation, you're going to get that with our product anyway. You're going to get that curve. As long as you load it with the weight properly, that curve every single time, no matter any other variables. So it's predictable, it's consistent, but most importantly, it's neutral. I think what happens here, this is audible for sure. And if I change any of those things, it changes again. But what I think is happening to the audiophile is that this is louder. Now, I haven't changed the volume of my equipment. The gain is the same, and yet I may be doing this subconsciously, but I'm hearing it's louder, and so therefore I'm being fooled into thinking that it's better. Obviously, it's not. This is coloration. This is an alteration to the signal that I don't want. I want neutrality, and I want consistency. So, with that in mind, when we're talking about mechanical isolation, we're talking about structural isolation, It's interesting to note that you have 4 arrival times. When you're listening to your speakers at home, you have 4 arrival times. You only want 1. The first arrival time is structural, it's mechanical. It's the loudspeaker vibrating the floor vibrating your chair, vibrating your butt via bone conduction to the inner ear. That is arriving before, because the denser the material, the faster and the further sound energy travels. That is arriving before the sound airborne from the loudspeaker to your ear. That's the second arrival, and that's the only one that you want. The third arrival is also airborne, and that is the bounces, the reflections off of the hard surfaces, and we can control those pretty easily. The fourth one is structural again. It's mechanical, and this is happening now after the, what was number 3, happening after the original event has stopped. So this is buzzes and rattles, or more likely resonances of the structure. If you take your fist in typical North American construction, 2x4 construction, take your fist and in between studs, do a little light fist bump, you're going to hear 70 hertz. And so whenever you play any music with 70 hertz in it, which is really any music you would play, it's going to sympathize with that, and it'll resonate, and it'll play back like a loudspeaker later in time after the original event has stopped. And so this is smearing, and it will smear everything. It's tonal, and it's going to smear imaging as far as soundstage. It's going to mask low-level detail. It's something that most people have never experienced. And again, like I said earlier, isolation of your loudspeakers has a huge impact. It's the easiest and least expensive thing you can do as far as acoustical treatment. So essentially, this is what's happening. You've got, let's say it's a full-rate speaker or a subwoofer. It's everything's hard fastened, so this is why you can hear the subwoofer at the other end of the building. If I isolate it now, the structure is no longer playing back just like a loudspeaker, but later in time. And you just hear the airborne, which is what you want. Okay, so from an acoustical upgrade point of view, the first thing you guys are probably doing is speaker listener locations. This is free. It just takes a little bit of time, a little bit of knowledge. You're going to get the bass optimized, then you're going to work on the sound stage, and then you're going to work on the timbre. And then isolating the speakers, this is a moderate cost. Like I say, we've got those up there. I can tell you about them. But this has a huge, huge bang for the buck. And then next, we're talking about internal, topographical acoustic treatments on the walls, the ceiling, and or the floors. And this can be inexpensive to expensive, depending. And then lastly, structural treatments. This is going to be the most expensive. This is going to control room modes and sound transmission. And doesn't have to be terribly expensive if it's new construction, though. So now we'll talk about electrical. And same thing. With acoustical, we've got this foundation that we need to have a level playing field. Same with our power quality. And unless we address it, we're kind of at the mercy of our electrical conditions, which again are all unique to us, depending on the environment that we're at and what we're dealing with. But on average, the listening room, as far as ground resistance, it's 25 ohms or more. I'm going to tell you that I've never run into a residence. Now, NEC wants to see 25 ohms or less at a residence. I have yet to see that. It's always been higher than that. And I'll give you some examples. We can easily obtain and want to get 5 ohms or less. We can probably get down to a half an ohm, and I'll give you an example. This is peak current capability. We want to, the average is dealing with less than 500 amps, and we want to see more than 1,000. Voltage distortion, you're dealing typically with more than 10%. We want to have less than 5. Common mode, normal mode, harmonic content, electrical isolation, again, most people don't know about it, aren't dealing with it at all, and we want to do everything that we can, all that's possible. So electrical issues, they can vary anywhere from introducing actual buzzes to hiss or other types of noise. But in general, I'll find that it will give the soundstage a very flat soundstage, not much depth to it. It can sound thin, it can sound very harsh or hashy. And again, unless you've experienced it otherwise, you don't know until you correct it. And then it's like when the HVAC goes off and you go, huh. No. So what can we expect to hear with such equipment changes, and can we expect to make fair assessments, and maybe we are compensated for them? Our objectives are going to be to minimize the potential to ground, to maximize the current delivery, minimize power factor correction, K-factor issues, minimize line coupled and field coupled, isolate critical components, and provide optimum safety for personnel and equipment. So it also means longevity. It's good for your investment. So with newer measurement equipment now, we have been able to realize more, and also I want to point out that definitely the trend of lower voltage circuitry with higher density integrated circuits and more RAM, and the increasing clock speed, this is technology is just going to continue. And we do so. We buy products certainly on a yearly basis that are just adding to the noise of our environments. And it's going to continue. It's not going to stop. So there are newer methods of grounding and filtration and isolation and bonding and so forth. And again, this is not only to improve the sound, but also the reliability and longevity of your equipment. And the results are, of course, safety and longevity, but also you're going to have a greater experience in dynamics, speed, resolution, and imaging in both audio and video. This is some general recommendations that anybody should be applying for electrical. Oversize everything. Overrate everything. Clean any visible corrosion or carbon deposits. Gas tighten wherever possible. And try to avoid other AC or signal cables by a good feet, try and avoid running in parallel with them. Cross at right angles and so forth. There's 3 ingredients that you want to be looking out for, and that is quality materials. And this goes to every contact right down to your cartridge pins. So from service of your power all the way to cartridge pins. Quality materials, large, smooth, clean, dry contact surface areas, and tight connections. And I recommend once a year, maybe twice a year, or if you're near the ocean, more than that, clean all those contacts with isopropyl alcohol or something. And you'll probably notice a difference in sound quality just by doing that and tightening connections. So I wanted to give you some examples. This is an example. This guy had easily a $1 million stereo system. And he didn't have anything special as far as electrical, just the standard electrical service. So I measured the grounding electrode conductor at his service entrance and found it to be 142 ohms. Not good. He wanted to address this in stages. And so we addressed it in, it's a fine order of stages to go in, but it happened to be least expensive to most expensive. So we ended up adding 2 what's called a technical ground. It's just kind of a special ground rods to the system. Not expensive, not difficult. He now has 0.53 ohms on his system, and it costs him about $1,000. and it makes quite a difference sonically. So that's something that's affordable and most people can deal with. We also then improved the configuration and the quality of his wiring going to, he had 2 monoblocks. We made dedicated circuits for those. We improved the wiring. We improved the outlet. We ran home run isolated grounds. And we put it in armored cable, and we made it all the same length. And then we made a third circuit for his preamp equipment. Guy's just an analog guy, just has a turntable and a phono preamp. And we went from, you see quite a bit of distortion going up to the 15th and 11.6 total harmonic distortion there. After doing that, then we ended up with 3.4 THD, and we barely got the third harmonic showing at all, and absolutely nothing above that. And this is his common mode before and common mode after. Oh, and actually, this is then with an isolation transformer. So this is a separately derived isolation transformer. There's a couple of companies that make good quality ones. Equitech and Taurus. They're specifically for the audio world, and they're balanced. Both of them are balanced, and they're pretty affordable. Canada, Taurus is Canada. So from electrical upgrades, ground resistance often less than $1,000 US. New cabling, moderate to expensive. Totally depends on your configuration, what your needs are. And then isolation transformer, that can be anywhere from 10 to 20K, again, depending on your needs. I believe there's we talked about a hierarchy. There's what I call a playback priority pyramid. You've got preparing the ground. You've got the foundation. Those are the coarse things. Those are the things that you need to have in place before you can get here. Because if you start tweaking and moving things, fine-tuning, without addressing this, you're just fooling yourself, chasing your tail, and being in confusion, and never getting to that audio nirvana that you want. Remember that the equipment will never be able to overcome the acoustics or the power quality. So there's 5 takeaways from my seminar today. There are fundamental sound quality attributes which are known and measurable. The typical listening room is pretty far off from the ideal, which lowers the performance of the equipment and the experience for the listener. There is a hierarchy in achieving sound quality. Coarse changes are required before fine-tuning can be perceived. Only a neutral environment can offer a fair and optimal playing field, and the biggest obstacles are often the smallest costs.